Good morning, good afternoon, Dr. Fogg and Dr. Lam. Today, I'm Timmy, and today I would like to talk about my feasibility study of my the renewable energy adoption in Hong Kong. So it all starts from the Paris Agreement in 2015, which many countries signed the Paris Agreement to commit with the carbon neutrality goal in 2050 or 16. And actually, Hong Kong government has allocated nearly 280 billion to address the climate change. They have proposed the Hong Kong Climate Action Plan in 2015, and there are actually lots of stakeholders think renewable energy is not workable because there are faced lots of challenges. For example, scarcity of resources, high population density, high rely on the fossil fuels of the traditional materials to generate electricity. So, but actually, I think in Hong Kong government, they have lots of development projects, which we can propose some solar project or wind. Yeah. It's okay? Oh, okay. So they have solar project or yeah, right? Okay. Sorry. Come on. Sorry. Okay, so I think there are lots of opportunities in Hong Kong, so I decided to do this project. So the aim is three main categories. The first one is to evaluate the feasibilities of implementing our system in Hong Kong. The second one is to evaluate with 3 sites, potential sites. One is in Kuching, one is in Castle Peak Power Station, and another one is in Southeastern Water with the offshore wind energy. Lastly, to examine the electricity self-sufficiency of renewable energy to proportion with the existing total power system. So the chart for today is as follows. I will talk about the background first, and then we got some mythologies, and then we have 3 different stories and 3 different sites. We got site assessment, resource assessment, and the site implementation. And lastly, we will have a summarize of the conclusion, which to cover up whether they can fulfill the self-sufficiency of the electricity or not. So let's talk about the background first. In Hong Kong, they got a subtropical climate with plenty of sunlight, which we have great abundance in sunlight, and also tropical cyclone winds with high average wind speed of 6.6 meters per second at Wetland Islands, given by the Hong Kong Observatory. And the size and coverage in Hong Kong, around 1,100 kilometers square, including Hong Kong Island, Kowloon Peninsula, New Territories, Lantau Islands, and other outlying islands. And we can see the power plant in Hong Kong major from 2. One is from CLP, another one is from HKU. They cover a different region in Hong Kong. So before we go to the self-sufficiency of the renewable energy distribution, we can see the weighting of our nowadays first. You can see, for example, solar energy and wind energy actually occupies only 3.7% in Hong Kong. And compared to the total energy systems, which around 286 terajoule, it only occupies for 0.9 or 0.3% only to the whole power system. In other words, we can see the contribution of renewable energy is not quite efficient, a great effect, or very small effect, or extremely small effect on the whole energy system. So I decided to use the solar energy and the wind energy as my feasibility study, since solar energy is comparatively easier to implement in our rooftop system, and wind energy actually can generate lots of energy to provide our daily use. And let's talk about a fundamental of photovoltaic system. And it basically is directly convert from the light into electricity by photoelectric effects and by some semiconductor materials. And we typically use semiconductor materials for PV panels, are usually used by silicon. And silicon, we got many types. For example, monosilicon, polycrystalline, monocrystalline, amorphous silicon, but we most likely use top 2 of them because they got higher efficiency rather than others. They got around 15 to 25%. And resources methodologies. Sorry. Okay, assessment methodologies. And if we need to assess for the solar resources, basically, what does it mean for assessing? So how does we assess the solar? We divide it into two parts. First one is the resources, and the second one is the site assessment. And considering the resource assessment, is used to evaluate the feasibility of the solar energy conversion system, including to characterize the solar irradiance for a specific region or location for a long period of time. Instead of using a physical measurement, we typically collect the data from open data source, for example, Hong Kong Observatory, planning department, or using the computer software, for example, Thesis, Global Solar Atlas, etc. This is the very basic or fundamental how can we consider for the solar resources. The most important parameters is used to collect the GHI, which is the global horizontal irradiance. The global horizontal irradiance can come from the direct path or from the reflected path, and it can be shown in the equation. So this is a demo that I used to calculate, which is an empirical model from the Angstrom type regression equation, which explains the relationship between the sun exposure hours and the solar irradiation. So how can we classify solar irradiance once we got the value? So if we see below 2.6 kilowatt hour per meter square, we classify as a poor or low abundance level, moderate for 2.6 to 3, high between 3 to 4, and above 4 is actually very high. And then the second one is how can we choose the site for our solar assessment? And basically, we need to consider, first of all, just like what I said before, GHI and the shading. And the shading, because shading is a crucial parameter. For example, if we put in the business district, it's hard to implement our solar energy. For example, there are lots of high-rise buildings in Hong Kong. They easily block the PV panels, just like in zero-carbon buildings. And we need to consider the land use and proximity of vacant land. For example, if we put into the developed land, it's hard to gather all the landowners or property owners to have a massive scale or utility scale of solar energy. So what can we use to select the site? In this project, I used, first of all, use the GIS, Geographical Information System, Global Solar Atlas, just like this map. We got the solar irradiation, the map. And last, from the EMSD, solar irradiation map, which is also used the GIS technologies. And this one, the first site that I would like to propose is in Kutong North, which is a roof grid connected PV system. Before I talk about the site assessment and resource assessment, I would like to give you a brief background regarding why I choose Kutong North. As you can see, the government start to have a Northern Link development plan in northern side, and then Kutong is actually earmarked as a new development area by Hong Kong government, and to address the city housing storage, and then a shortage, and then they want to build a new CBD over there, and we could expect there are 27 buildings in the development zone. And then, so I would like to put all the PV panels over there. As you can see, just like here, we got lots of buildings over there, and then we hope to put all the PV panels over there, and then see what it generates at last, and then can it self-sufficient for the town over there. And the second one, just like I mentioned, we need to see the global horizontal irradiation or the solar irradiation. We can see from the EMSD chart map, we can see most of them from the legend are excellent. And then just like some of the buildings are quite poor. And then after I go to site survey, and then I found that there are lots of trees blocking them. And then it's expected that if after construction, it can be removed all the trees. And then we'll come up with a high abundant radiation. And then I would also conduct shading analysis over there by using the ArcGIS, and I have made a 3D model over there. The 3D model, as we can see, from 6 a.m. to 6 p.m. And then you can see the shading from 6 a.m. is the sun hasn't rise yet. And then until 8 a.m. and then it starts to rise, and then it has no shading cover until forward. It got a bit only on the shading, and then it lasts 1800, and then most of them are shade or covered because the sun starts to fall. And this is the winter shading. Just right now, I show the summer shading because there's some part at the summer and winter are different. And then winter actually they got the sun exposure hours are quite short, with later time to sunrise and then early time to fall for the sun. And you can see comparatively in the 4:30 p.m. and then most of them already shaded for the buildings. So so after that, we have to consider we can't use the whole rooftop for PV shading. We got other, for example, HVAC and then other equipments. So after calculation, we can find that by the researchers, we can see only 27.4 times the DFA, which is the gross floor area, can be used for implementing the solar resources. And this is chart I calculated. And the second part, just like I mentioned about the site assessment, this is the resource assessment from the HKU, Hong Kong Secretary. We can see the global horizontal irradiance comes to 3.15 to 4.62. And just like I mentioned, 3 to 4, this range is actually highly abundant for the solar irradiation. And the highest is occurring at the August. And we can see at some season beyond 4 kilowatt hour per meter square, which is classified as very high solar irradiation. And moreover, and then we can see the seasonal variation of global horizontal irradiation can be summer is the highest, while the winter is the lowest. Okay. Just like I mentioned about the empirical models, we have to see the relationship between the sun exposure hours and the global the solar irradiation. And then we can see the monthly average of the sun exposure hours is 154 hours. We can see the trend line is basically the same, having a positive correlation with the solar irradiation. Yes, I also collect from various databases. For example, Red Screen, Global Solar Atlas, Thesis. We can see similar GHI share within 3.8 something to 4 something. And then we found that the optimal ceiling angle is around 19 degrees to 23 degrees towards south. And after that, I have implemented. Okay. 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 So,
Oh, I see. Well, I noticed that this is just halfway. You have one slide, and you have around 27 only.
Okay. Okay. No problem.
And appreciate that you've done a lot of work.
Yeah. I will speak up. Yes. Yes. Just most of them are graph only, not for yes, just for illustration. Still can't.
You don't need to pay more.
Because I can't see the screen. So yeah. Okay. Is it clear? Is it okay? Okay. How about Okay. So funny. Okay. Okay. So the next one, I'll try to speed up. And then the second site is actually similar, which is implementing the PV at the Castle Peak Power Station. Castle Peak Power Station basically owned by CLP, and then they use the coal-fired power plant, and then however the government forced to stop the coal power plant in upcoming 10 years, and then so this is a potential site for us. For example, these two coal storage is my potential site. And then since coal will be run out, okay. And you can see the solar irradiation nearby is quite good, excellent to good. And then we can estimate the area by GIS. And then shading analysis, similarly, we can see although there are some buildings nearby, they do not have cover for the shading. We got these two areas, but they do not have a great effect or just a minimum effect. And then lastly, we got the implementation result here. We can generate around 200 gigawatt hours, which if we consider for a residential household use, we can cater for around 60,000 people, but not for per capita. We will analyze it later on. And this is the monthly system power generated by SAM. And last but not least is the wind energy at southeastern water. And then this is the method that we use to analyze the site assessment. We can see for offshore wind farm, and then their wind power density is much greater than in coast area. And then by GIS, the data is from the UST. And then we can see in coast area, the average wind speed is around 3 to 4 meters per second. But if we put it in the offshore wind farm, it could up to 6 to 9 meters per second in this range. And then we have to consider wind speed, wind power density, and also the wind direction when we design a wind energy turbine or a wind farm. And this is just like what I said. And then in this project, I have used a Y-bound distribution, which is comparatively to normal distribution, is more accurate for wind assessment because it can left scale or right scale. And then this is also covered the wind power density calculations. And we can classify if we for greater than class 3, it is highly suitable for utility scale wind power applications. And then yes, and then for 4 is highly preferred.
Only 5 more minutes. Okay.
Yes, 5 more minutes can all to be catered. Yes. Okay. This is the last one, the southeastern water, which is recommended by CLP in April 2006, and then which is nearby Basset Island and then Nine Pin Island. And then the preliminary profile would be like this. I used the SAN to conduct the wind layout for this wind turbine layout. And then you can see the wind roads provided by planning department. And then most likely it's from northeast. And then the annual wind speed is around 7 meters per second. And then the wind power density is 200 something watt per meter square, which is class 4, is belongs to strong recommend. And this is the frequency distribution. Typically, most of them lies between 6 to 9 meters per second. This is the Y-bar distribution with it 5 to 7, with the heights in 6. And then this is the data from HKU. Because HKU, they do not have a particular site in southeastern water. So I use a similar within Wetland Island, and they share the similar approach. And lastly, after using SAM with the Vestas V112 with 3 megawatt output, I have designed a 150 megawatt turbine, and it can generate 4.98 to 10 to the power 8. And then we can see they cover, if we consider per capita, electricity per capita, and then they could only cover for 80,000 people. However, if we consider for residential use, it could cover around 1.81 million. So this is a summary for solar energy. Although we got large implement scale of wind solar energy in the rooftop, however, it could only generate for 41.96 in the Kusong North, and then 190 something in CPPS, which is the Castle Peak Power Station, which is relatively lower than wind power. And then the contribution is not too great. And then so although, and then this one is for the wind energy. This is the last part. And then wind energy, although they got, you can see the numericals, is it very numerous? It's a very big scale of the energy. Sorry, should be a very large amount of energy can be generated by the southeastern water wind turbine. However, it could only contribute from 0.9% to 1.5% by the southeastern water. So I can conclude that it cannot be fully rely on the renewable energy. We have to find another solution. But this could be help us to supplement for part of the total power system. So okay, thank you.
Good. Okay, very good. Already comprehensive.
Thank you.
Any questions?
Yeah, now in your analysis of the PV, you mentioned that the best performance ratio was achieved in October, and that was only 80%. And I know that have you calculated the overall performance ratios over the year?
You mean the PV plants?
Yeah.
Yes. Should be the second slide, right?
No, down there you mentioned how the performance ratio achieved this one.
Okay.
That's what you mentioned about.
Oh, this is calculated by year with 10 minutes interval. They have generated with the performance ratio with 80%. But they in here, because the performance ratio may some depend on some factors, for example, some shading loss or other losses. In this study, and then the shading loss have been covered in the PV area. You can see the PV area is relatively smaller than this because I have considered the shading there. I have the array distance for over there.
So regarding this, are you sure that CLP will get rid of using the coal and then the coal fuel storage?
They actually have a plan of implementing the energy storage instead of PV panels. But this is, I think, for a feasibility study, I could provide another more option for them to consider. For example, other than the ESS, and then I can put on top of them.
Yes. What is your job? The full-time job?
I will go to MPR next month.
Okay, are you in CLP or?
CLP not yet, but I worked in Huawei before, so I want to memorize with the ESS and the PV.
Seems like you know a lot of insider information.
Yeah.
So this figure is the annual performance ratio.
Yes. This one is the AC energy output, and then we can see classified into different months.
No, I'm talking about the performance ratio.
Performance ratio.
This is the annual one, the 80.
Yeah. It's annual one. Yes.
Frankly, 2.34 is not accurate.
Okay.
Yeah.
Okay, thank you. Thank you. 咩啊？佢做 main 市啊，做 main 市。係啊，翻 shift 啊。
好，咁啊，
多啲錢咯。
唔係
好高人，
應該第時
佢 CLP 有 offer 嘅，但係 CLP 我覺得會跌地嚟㗎。
地址應該少少壞㗎，我哋識加入啲學校。
應該希望啦。
好，再見。
好。